Question 12, Part D. Let A, 0, -k be a fixed point on the y-axis with k greater than 0. The point C, t, 0 is on the x-axis. The point B, 0, y is on the y-axis so that triangle ABC is right-angled with the right angle at C. The point P is chosen so that OBPC is a rectangle as shown in the diagram. Part 1. Show that P lies on the parabola given parametrically by x equals t and y equals t squared over k. The y-coordinate of P is equal to the y-coordinate of B. Now P and B are vertices of the rectangle such that PB is parallel to the x-axis. That implies that P and B are the same distance away from the x-axis. Now the x-coordinate of P is t, hence x equals t. In right-angled triangle ABC, AB squared equals AC squared plus BC squared using Pythagoras theorem, where AB is the hypotenuse. Now AB is equal to y plus k. So y plus k in brackets squared is equal to k squared plus t squared plus y squared plus t squared. Expanding the brackets on the left-hand side, we have a perfect square. We get y squared plus 2yk plus k squared is equal to k squared plus t squared plus y squared plus t squared. Now the y squared and the k squareds on both the left and the right hand sides will cancel, and we're left with 2yk is equal to 2t squared. We get that by combining the t squareds here and here, since they're both like terms. Dividing both sides of this equation by 2, we get yk is equal to t squared. And then dividing both sides of the equation by k, we get y is equal to t squared over k. Therefore, P lies on the parabola given parametrically by x equals t and y equals t squared over k as required. Part 2. Write down the coordinates of the focus of the parabola in terms of k. Since x equals t or t equals x, the equation of the parabola in Cartesian form is y equals x squared over k. And since k is greater than 0, this represents a concave up parabola with the vertex at the origin. That means the focus is above the vertex. Now, rearranging this equation to make x squared the subject, we get x squared is equal to ky, and this is in the form x squared equals 4ay, where a represents the focal length, which is the distance between the vertex and the focus. So k is equal to 4a. Dividing both sides of the equation by 4, we get a is equal to k over 4. And that's the distance from the vertex to the focus, and the vertex, or the y-coordinate of the vertex, is 0, so adding k over 4 to 0 just gives us k over 4. Therefore, the coordinates of the focus is 0, k over 4.